So starting with number 20, they're hoping that you're going to be intimidated by the multiple square roots, or that you will make a simple mistake when getting rid of the square roots. The trick is just to copy down the question correctly. We're going to take that A, and we're just going to plug him straight into that A. That's going to be 2, 5 root 2 equals rad 2x. This is the same as just 2 times 5 times rad 2, or 10 rad 2 equals rad 2x. Now I have to get rid of the square root, so I am going to square both sides. That gets rid of that root right there. Don't forget to distribute the square. Don't just square the rad 2 and forget to square the 10. That's the trap. So this is going to be 100 times 2 equals 2 times x. I get rid of both of those 2's, and x is just equal to 100. For number 19, the fastest way to do this problem is to know the trig rule. Sine of x is equal to the cosine of 90 minus x. That way, when they tell you that sine of x is equal to 4/5, and when they ask, it just has to be 4/5. That's all you have to do. If you want to demonstrate for yourself that this is the case, you can still make a right triangle. So we're going to make this guy right here x. And following SOHCAHTOA, sine is opposite over hypotenuse. This is a right triangle. So x plus 90 plus this guy right here have to equal 180. That means that this has to be 90 minus x, because that's the only way these three boys will add up to 180. So cosine of 90 minus x, cosine, SOHCAHTOA again, adjacent over hypotenuse, 4/5. Number 18 is a system of equations. Because this is a medium to hard problem, the quicker and easier method is going to be to use combination rather than substitution. You can still use substitution, but it's going to take you longer. So just to start, we're going to layer them up on top of each other. So you could just subtract down and get the y. However, notice that they are asking for x. They don't want y, they want x. So we want to make it so that the y is what cancels out. To do that, I'm just going to multiply the top by -2. You can multiply this by 2, and you'll still get the same thing. Here's what I mean by that. When I multiply the top by 2, I get -2x plus -2y equals positive 18. X, 2y, -25. Because this is negative and this is positive, I'm going to add down. If you multiply this by 2 right here, you can get the exact same thing by just subtracting down there. So this is going to get us -x. That cancels out. And this is equal to -7, or x equals 7. So for number 17, this problem is all about labeling correctly. Here's what I mean by that. They tell us in the second sentence what each of these distances are, or what 4 of the distances are. So just go through that sentence slowly and carefully and label each of these guys correctly. So AB, 1800, EB, 1400, BD, 700, CD, 800. So if this makes sense to you, if you can kind of wrap your head around what side corresponds to what side on each of these two triangles, then you can jump straight into a proportion. However, for most of you, this is probably hard to wrap your head around because while these are two similar triangles, they don't look like they're similar triangles. They're not oriented in the same way, which can make it difficult to figure out what side corresponds to what side. To get around that, you just want to redraw your triangles. And we're going to redraw them so that they look the same. So I know that because I'm drawing them the same way that both of these guys right here must be B, because that's how the big triangle is oriented. I'm going to make the small triangle oriented like the big triangle, which means that big triangle is exactly the same as it appears up here. They very conveniently label for us that D is equal to E. So this must be D, and then that must be your straggler C. Now you just relabel the distances. If you're going this option, you know that this makes more sense to you. skip actually labeling your sides until you hit this point right here. You'll save yourself some time. So then C, D, 800, B, D, 700. So this is a lot easier to wrap your head around. Notice, fastest way, this is just times 2 to get that. And since they're asking for what is the value of x, and in the first sentence they tell you that the value of x is this guy right here, we know that the correct answer is just going to be 800 times 2, or 1600. And that's your answer. You can still get this by creating a proportion with 1400 and 700 and x and 800. Number 16 is technically an easy problem. That's because the free response section resets the difficulty. So number 15 will be hard, and then number 16 will be easy. So you can get this wrong if you have difficulty switching gears from thinking about hard problems to thinking about easy problems. You can make the math more complicated than it needs to be. So for this problem, it is literally just manipulation. We're going to add 4 to both sides, is equal to 4. T is equal to the square root of 4 plus minus 2. This is where we bring in at t must be greater than 0 back from the problem. All this is saying is that we give them the positive version because you can't give a negative answer on the free response section. That's all that's there for. So for number 15, to get this problem right, you need to understand that when two quadratics are equal for all values of x, their a values are the same, their b values are the same, and their c values are the same. So what do I mean by that? Ax squared plus bx plus c is equal to dx squared plus fx plus e. A equals d, b equals f, c equals e. So we're just going to pull this concept into number 15. Start by foiling out ax plus 2, bx plus 7. You should get something like this. Notice you have two b values here. If I pull out an x just out of these two right here, I pull out an x, I get 7a plus 2b x. This is my b value now. Now I'm just going to layer up the other quadratic underneath it. Notice this guy is c, this guy is 15. 14 is equal to 14, irrelevant. So now I'm going to rewrite out these equations. I have ab now equals 15, and 7a plus 2b equals c. And then I go back to the question to pull our final third equation, a plus b equals 8. With this is no longer a quadratic. Now it's just a system of equations. And they are looking for c, so I need to first find a and b. I'm going to use these two equations to find what a and b are. Start with ab equals 15. What possible pairs of numbers can multiply to 15? We only have 1 and 15 and 3 and 5. Which of these two sets could add to be 8? Only 3 and 5. That means a must be 3 while b is equal to 5, or a must be equal to 5 while b is equal to 3. Those are the only two options, but because it doesn't matter what order I put it in for either equation, both of these two are options. That's why the problem is asking you what are the two possible values for c. Now I'm just going to pick one and plug it into my c equation. I'm going to pick this first one right here, a equals 3, b equals 5. So that's going to be 7, 3 plus 2, 5 equals c, 21, 10, 31. Notice only one option gives you 31 as a possible answer. You can stop right there. You don't even need to figure out what a equals 5, b equals 3 is. You have your answer. And this is the exact same regardless of whether you started with this one. A equals 5, b equals 3 is going to get you 41 as an answer. And notice no other answer choice has 41 as an answer choice either. So you only need to solve one or the other, and then you can stop. You have the correct answer. For number 14, I am going to guess that the majority of you tried to take this and turn it into a system of equations with the 8x2y. You can do it that way, but it's not the easiest way to do it. The easiest way to solve this problem is to just take a look at this guy to start. So you have 8x2y. You can't do anything with this unless they have the same base. So you have to ask yourself, 2 to what power will get me 8? 2 to the third will get me 8. So this just becomes that. When I have two exponents with the same base and they are dividing each other, or one is dividing the other, I subtract their exponents. So that's going to be 2, 3x minus y. Notice 3x minus y, 3x minus y. 2 to the 12th is just your answer. So you have 1 over x plus 2 plus 1 over x plus 3. This 1 over at the top right here is exactly the same as a negative to the power of -1. So this is exactly the same as this. Thinking about your exponent rules, practically speaking, if I had, say, 5 over 3 to the -1, that's the exact same thing as 3 over 5. So I'm not going to worry about the -1. I'm just going to solve what's inside the parentheses, and then when I get to the very end, I'm just going to remember to flip them. So when you think of it that way, this problem, it's just adding with fractions. I just need to get these both to have the same denominator, which means multiplying this guy by x plus 3 and this guy by x plus 2. So that's just going to look like this, and I'm going to just save myself some space by starting with the denominator, and then I'm just going to add them both on top. So this is just equal to that. What's inside is just equal to this. So now I just need to add the top and FOIL the bottom, flip, and then I have my answer. So adding the top, I get 2x plus 5 over x squared plus 5x plus 6. Now I just flip, x squared plus 5x plus 6 over 2x plus 5. And that's my final answer. For number 12, they give us the slope and the y-intercept. They give us that the slope is 1/7, and they tell us that it passes through the origin, so the y-intercept is just 0. At this point, all we have to do is plug and chug our answer choices in until we find one that actually works. So for example, if I wanted to check A, I would plug in 0 for x and see if I got 7. So I plug in 0 for x, and I get 0. So that doesn't work. You're going to keep doing that until you find one that does work. In this case, you're going to find that 1/7 times 14 is equal to 2, and so 14/2 works. Number 11 is a word problem plus system of equations. So what we really need to do is we need to parse out what this question is actually asking us to do. So we have B and C represent the price per pound in dollars of beef and chicken respectively. So from that, we just need to know that B equals beef and C equals chicken. What was the price per pound of beef when it was equal to the price per pound of chicken? You can parse out that word soup, and you can shorten it down to what was the price of beef when it was equal to the price of chicken. So I want to know what was B equal. And to do that, I need to set these two equations equal to each other. I'm going to get x, but I don't want x, I want b. I'm going to take that x, plug it back into the b equation. So we start by setting these two equations equal to each other. So we just need to subtract 1.75 from both sides, 0, 13, 6.0, plus minus 0.25 minus 0.25 equals 0.15x. So to start, I'm going to move both of these guys like that. I don't want to deal with dividing fractions. So we're going to multiply both sides by 100 and make them whole numbers instead. That means x is just equal to 60 divided by 15, which is just going to get you 4. Plug that 4 back into the equation. We just get 25 times 4. 4 times 0.25, nice and easy, just 1, plus 2.35, 3.35 is your final answer. For number 10, you need to understand how to work with functions. As a quick reminder, g of x is your input, g of x, the whole thing, is your output. So when they tell you the g of 4 is equal to 8, what they're saying is that when I plug 4 in for x into the ax squared plus 24 equation, when I plug 4 in here, I'm going to get out 8. Shortcut, notice, what are they asking for? They want the value of g of negative 4. If I were to plug negative 4 in here, would anything change? No, because a is still the same, and plus 24 doesn't change. And negative 4 squared is the exact same thing as 4 squared. So if you notice that, you know that your answer is just going to be 8, and you don't have to do any work. If that doesn't come to you right away, then you're going to need to work through all the math. So we're going to subtract 24 to both sides. We get 16a is equal to negative 16. Therefore, a is equal to negative 1. So now I update my equation. I get negative 1 x squared plus 24 equals the g of x. So now I'm going to take this guy, plug in negative 4. You work through the rest of this math. You get 16 plus 24 equals 8. Same exact thing. Number 9 is another system of equations, so you can use either combination or substitution. But again, this one is going to be faster with combination. So that's what we're going to show off. We need both x and y, but take a look at your answer choices. Notice that there are 2 y's that are exactly the same. So if you want to save yourself some effort, you need to look for the x because all 4 of your answer choices have a different x value. So to make your life faster, we're going to solve for the x, not the y. Let's start out by just copying it down exactly as it appears. And then we need to move this so that they are on top of each other rather than on opposite sides. I want to get x alone, which means I need to multiply the bottom by negative 2. Negative 2 makes this 3x plus 4y equals negative 23. Positive 2 minus 4y equals positive 38. So now, because these are opposites, positive 4y, negative 4y, I'm just going to add down, and that gets rid of that. 5x is equal to 15. 38 minus 23 is 15. So x must be 3. You pick the answer choice with x equals 3. For number 8, this can be a little bit wonky, but you want to approach it from the mindset of how do I get a over b to become 4b over a. So we're just going to think about what steps does it take to get from here to here. So first step, I notice that b and a are flipped. That means I need to put them to the power of negative 1. I also notice that I got a 4 over here. Multiplying the top by 4 is the same thing as multiplying the whole thing by 4. So if I multiply this to the power of negative 1 and then multiply the whole thing by 4, I will get this. So now all I have to do is do all of this to that 2. They tell us AB equals 2, so I just do the things that I was doing to the AB to the 2. So 2 to the negative 1 is 4 times a half. 4 times a half is 2. That's your answer. Number 7 looks like a monstrous, intimidating problem. It's actually very, very simple. What are they actually asking you to do? They're just asking you to make this equation, which is essentially m equals 2 big monsters over 1 little monster times p. That's at the core of the equation. When they ask you for getting p alone, they just want you to move this fraction to the other side. To do that, you're going to multiply by the inverse. So the shorter guy goes on the top now because he's going to move over here, and the longer guy goes with the m. So that gets rid of that. So now I'm just going to copy this guy down here. I have the 1 parentheses and the 2 parentheses times the m equals p. So to write that all out, you're going to have your 1 parentheses. Reading your problem is just 1 plus r, 1200, and minus 1, R 1200, 1, R 1200, N, N. And that's it. So if it helps, you can also change your original equation so that instead of thinking about those really long parentheses, you're thinking of the long one and the short one. You can just rewrite it that way. It'll be the exact same thing because you're not moving anything around in this fraction right here. You're literally just moving this fraction to the other side, and that's the entire problem. For number 6, you need to know how to read an equation. You don't need that whole first sentence, you just need the last one. You just need to know, based on the model, what is the estimated increase in inches of a boy's height each year. Estimated increase, think of that as a rate of change, which is the same as a slope. So 3 is just going to be your answer. Number 5 is not particularly difficult. It's just very easy to make a mistake when you distribute that negative. So you just want to be extra careful that you're distributing that negative accurately. To do that, I just literally rewrite the problem. Switch, 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 switch. Next, to make your life even easier, you can draw physical circles around what matches. So x squared y, 1 plus 1, 2x squared y. Negative 3y squared. Notice that's not this guy right here, that's this guy right here. Negative 3y squared, positive 3y squared, they cancel out. Last up, this guy, positive 5xy squared minus 3xy squared is going to be a positive 2xy squared. And that's your final answer. Number 4 is another problem where they're asking you to read an equation. So they tell you that each week she receives a batch of phones that need to be repaired, and the number of phones that she has left to fix at the end of each day can be estimated with this equation. So based off of that, if P is equal to the number of phones that she has left to fix, and D is the days that she has worked, this is telling us that she repairs about 23 phones a day, which means she must have started out with 108 phones. So that's your answer, 108, which is what they're asking for. What does 108 mean? The number of phones she started out the week needing to repair. For number 3, you want to start out by translating the very first sentence. So Armand sent M messages every 5 hours, and Tyrone sent P messages every 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? So your answer is just going to be 5M plus 4P. You could get confused by the wording of the actual word problem itself in the first sentence. If it makes it easier for you, you can give a value to M and P. Instead of saying Armand sent M messages for each hour for 5 hours, you can say Armand sent 2 messages each hour for 5 hours. So in that way, 2 would equal M. And you can also say that Tyrone sent 3 text messages each hour for 4 hours. So Tyrone 3 would equal P. You just plug these in to your answer choices and figure out which one works based off of what you determine the answer to be. However, the answer just needs to be the sum of the total number of messages they sent.
For number 2, don't get intimidated by I. Just treat him like an X until you reach the very end of the problem. So treating I like an X, notice, do we have any multiplication? No, which means with or without these parentheses, this is going to be exactly the same. So we can just drop these parentheses and nothing else about the problem will change. At this point, we just want to add our like terms. So we're going to add this 7 to this negative 8 and this 3i to this 9i. So doing that, we should get negative 1 plus 12i. So because we're treating this I like an X, we want to pause right here. We've done as much simplification as we can. If we had an I squared, we would have an extra step. But since we do not have any I squareds, we're done, and this is just the end of our problem.
Finally, number 1, we are just going to do a little bit of substitution. So we substitute that into there. And then it's just manipulation to get x. So we go x minus 1 equals 9, x equals 10. And that's your final answer.